Hi, I'm Shwetha and I'm going to tell you about my REU project. The Newman lab at Cornell has an electron beamline called Medusa. This is basically a bunch of negatively charged electrons, accelerated to nearly half the speed of light. This beam of electrons is then focused on a small sample material. The electrons interact with the sample on a nuclear scale and strike a detector placed after it. This gives us information about its nuclear properties. In the same way a ray of light can be focused to a small point, a beam of electrons can be focused to a more narrow beam using certain types of magnets called solenoids. A solenoid creates a magnetic field that can make the radius of an electron beam smaller. For the first half of my project, I ran simulations of various solenoids on a software that can predict the trajectory of a beam. The goal was to arrive at a design that can focus the electron beam the size of a couple of microns, which is basically 1/1,000,000th of a meter. Once I figured out the optimal values, we built the solenoid, 4 inches long and 2 inches wide. It eventually goes into a vacuum chamber, so all the materials used have to be specifically vacuum compatible and clean. It's made of a sheet of copper with insulating tape on one side, wrapped around an aluminum rod. We then gave it electricity and verified that the magnetic field it produced followed what we predicted. Once we built the solenoid and a structure to hold it in place, my mentors and I cleaned it up with alcohol in a machine called a sonicator to remove all the dust. The components can have more impurities than just dust, like volatile material or other molecules that can stop the vacuum pump from being able to create a good vacuum. To clean it further, the components are being baked with heat. Once this is done, the solenoid will be installed into the actual vacuum chamber and can be used to study various materials that can contribute to fields such as engineering and medicine.